Alright, so here's our second video. This is to help you with the worksheet that I gave you today in class. Describing transformations of quadratic functions. The first two things are the same thing you wrote on your notes. That f of x is the same as y. Okay, it's just a name. And it is your pre-image. Alright. Now we're going to do an example where we write the function notation of the transformed image. So the example says transform the graph f of x equals x squared plus 2, write 4 units and flip. Okay, so function notation for that will look like this. The negative is 4 flipped. Then we have f of x because that's our function. And it says minus 4. Okay. It says write 4, so we're going to write minus 4, sorry. Alright, so that would be our function notation. Negative f of x minus 4 close parentheses. Alright, so sometimes your problem will say that your transformation results in a new function, okay, called the image. Okay, it can be f prime of x, or it could be g of x, okay, something like that. But your problem will state what it is. And so our image for this function, because we moved it, we flipped it and we moved it right forward, our image would be g of x equals negative x minus 4 squared plus 2. Alright, so you see we added the negative to the original function, and then we also added in the minus 4 next to the x, because that moves our graph to the right, and then we kept the plus 2 because that didn't change. Alright, images. I'm sorry, let's go to the next example, number 7. It says the function f of x equals 4x was replaced with f of x plus 5, resulting in the function g of x. What is the distance between the y-intercept of f of x and the y-intercept of g of x? First thing, identify your pre-image. So the pre-image is f of x equals 4x. Now you want to identify the transformation. The transformation is f of x plus 5. And that's going to result in g of x. Okay, now you want to plug the transformation into the pre-image. So f of x plus 5 is going to change f of x to look like this. 4x becomes 4 times x plus 5. Because here, the 5 is inside the parentheses of the x, so we should show that the same way in our function. Alright, so now we're going to simplify. So we know that f of x plus 5, that f of x plus 5 will be g of x. And so I'm going to write this again. So this should become g of x. And then I'm going to distribute here. 4 times x is 4x, and 4 times 5 is 20. You will not have to do that in every problem, but we're going to do that here because this is a linear equation, actually. And our question is asking us about the y-intercept. So in order to find the exact value for the y-intercept, I have to distribute 4 times 5 is 20. All right, so now let's identify the y-intercept and compare them. Final step. Compare the y-intercepts, because that's what our question is asking us. Other questions may ask you to identify x-intercept or compare x-intercepts and compare slopes or anything like that. This one asks us about y-intercepts. So compare the y-intercepts. What's the y-intercept of g of x? Is 20. Now, what is the y-intercept of f of x? Is 0. Because you don't have a plus or minus number here. Okay, so you have to assume it is 0. Alright, so what is the distance between 0 and 20? It is 20 units. Alright, one more. We have which function g of x possesses, which function g of x possesses function values that are 2 less than those of f of x equals x squared. First, identify the image. So, our pre-image. That is f of x equals x squared. And then our transformation. Okay. It says 2 less than our function, so that would be f of x minus 2. F of x is our function, so 2 less than will be subtracting 2. Now we want to plug in that transformation, and this becomes g of x. I'm sorry. So now plug it in. We have f of x minus 2 equals x squared minus 2. So g of x equals x squared minus 2. So your answer is B. If you have any questions, ask me or post them on Google Classroom. And I'll see you guys next week.